Hello, and welcome to Schwug's Summer Camp 2013 virtual conference. My name is Craig Mullins. I'm an independent consultant, and I focus on database performance, database administration, and with a particular focus in DB2 for ZOS. And today, I'm going to talk to you about 10 breakthroughs that changed DB2 forever. And this is basically a short walkthrough of the first 3 decades of DB2's existence. Our objectives today are going to be to get a historical perspective of DB2 and how its features and functionality have changed over the course of the past 30 years. And we'll look at the 10, in my opinion, the 10 most important technological breakthroughs that have caused DB2 to become the high-speed, enterprise-capable DBMS that it is today. We'll look at these breakthroughs not in order of importance, but in chronological order, the order in which they were first introduced to DB2. We'll talk about the version where it came in, and then we'll expound a little bit on the individual feature and its significance in terms of how DB2 changed as a result of that feature being available. Towards the end, we'll take a look at a few of the breakthroughs that didn't make it into the top 10, as well as explain why they didn't, and maybe look at what's coming in the future for DB2. So with that in mind, let's take a look at the history of DB2 for ZOS. The DBMS DB2 was announced in June of 1983, June 7th to be precise, and I did a little bit of digging and tried to come up with the historical timeline of DB2. And you can see here I produced a graph with the version, the date the actual version went GA, that's general availability, and then for later versions, the end of marketing and end of service date. EOM is end of marketing, and that's when IBM stops selling the product. You can no longer buy that particular version. And end of service is when IBM stops supporting that particular version of the DBMS. So one of the things you can see here is that the delivery of new versions has slowed. In the early days of DB2, every year, 85 to 86, 86 to 87, 87 to 88, we'd see a new rev of the product be released. And now, if we look at the past few releases from 7 to 8, 8 to 9, 9 to 10, we're on a 3-year release cycle. And that's kind of holding true even as we look at what's on the horizon with DB2 version 11. That seems like it's going to be coming out later this year, probably the fourth quarter, and that would put it right in line with a 3-year delivery cycle between 10 and 11. The other thing to take note of here is that in the early days of DB2, IBM would come out with point releases instead of just pure new versions. So we see 1.1, 1.2, 1.3, 2.1, 2.2, 2.3, and these point releases would come out much more rapidly than a new version of DB2 gets delivered. Now, you may ask, why did IBM stop coming out with these releases instead of versions? And there's probably a number of different answers there. One would be a marketing answer, and again, this is my opinion only. You see Oracle with Oracle 11, Oracle 12, you're coming up there with the larger numbers, and if IBM had kept coming out with point releases, the version would look a lot smaller than what some of the competitors have. But then also, it's what's the difference between a version and a release? Basically, not just with DBMS software, but any system software delivered by vendors, a version is a major concern, and it has a lot of changes and a lot of new features, whereas a release is going to be more minor. Fewer changes, not as many new features. So it's all based on the amount of change that gets introduced into the product. The more change, the more likelihood that it's a version instead of a release. One thing to keep in mind, though, is regardless of whether you're migrating from version to version or release to release, it probably doesn't indicate that it is a simpler process to do a release to release migration. It's really going to depend on the nature of the new features that are in each of those specific releases. So you've got to plan and go through the stages of migration, whether it's a version or a release. So basically, what we have is in the early days of DB2, 1983, 30 years ago, our DBMSs were not the norm. People didn't have relational systems. They had hierarchical or network codicil databases for the most part, or inverted list DBMSs, and relational was brand spanking new back then. And when version 1 of DB2 came out, it was thought of by most people as an information center product. And unless you've got some gray in your hair, you don't even remember that term. An information center was more of an IT related application, or maybe even an analytical type of an application, kind of what data warehousing and BI evolved into, but not exactly. So it really wasn't geared or thought to be geared towards transaction processing. But over the years, as new features and functionality became part of DB2, it turned into a high-performance, feature-laden OLTP DBMS, but also capable of delivering data warehousing and analytical capabilities, all with high availability and advanced administrative and management capabilities. So we're going to look at the 10 breakthroughs that changed DB2 into the DBMS that it is today, starting with number 1. Version 1.3 introduced the date and time data type. Prior to that, there was no date and time data type in DB2. So people would design their tables such that the dates and times would be using a character or a variable character, or in some cases a numeric field. And this led to some data integrity problems. There was no validation of the data. You couldn't perform date-time arithmetic very easily, and because just subtracting a number from a number that's a date, you're not going to get the right answer. You have to understand that it's year, month, and day. And just in general, wound up with bad quality. On a side note, I answer questions for online portals quite frequently, and one of the questions I get regularly is, I've got this table and it's got a character 10 column and it stores dates, and what I want to do is, and they explain what they want to do with it to operate on it like it's a date. And I've got this boilerplate text and it says you shouldn't have done that and here's why, and I talk through what I just talked through, and then I go and try and help them solve the problem. But my point there is that people today sometimes still design their systems as if version 1.3 didn't happen and there are no date and time columns available. So the general guideline is that you should use the proper data types. You want the database system to do the hard work for you. In other words, specify the data type as close to the domain as possible. If it's a date, use a date. If it's a time, use a time. If it's both a date and time, use either one date, one time column or a timestamp column. And doing that means that DB2 is going to do your data cleansing for you. You can't store a non-date data value in a date column. DB2 just doesn't let it happen. So all that work that you were putting in your program, or not doing at all, that would cause data integrity problems in your character columns, DB2 takes all that work on and does it efficiently and effectively. The ability to do date and time arithmetic is an additional important consideration. You can add and subtract these chronological data types and come up with dates or times in the future or the past, or a date, time, or timestamp duration. which means we need to understand what durations are. There are 4 types of durations broken down into 2 categories, labeled and unlabeled. Labeled durations are pretty simple. It's specified as a number and a qualifier, 2 years, 33 minutes, 10 days, 1 second. So you can say column, that's a date column, plus 10 days, and DB2 will add 10 days to that, give you that date in the future, whether it's in the same month or a new month. The unlabeled durations are specific formats that need to be coded the appropriate way and used in the right context, and then DB2 will recognize them as a duration. So there's an unlabeled date duration, an unlabeled time duration, and an unlabeled timestamp duration. So as long as you have it specified as decimal 8, 4 characters for the year, 2 for the month, 2 for the day, and then the example here, 00201104, and we take that and we add it to or subtract it from a valid date variable or column in DB2, then DB2 will take the 20 years, 11 months, and 4 days and subtract or add it and give you that date either in the future or the past. Likewise, time and timestamp durations, as long as you have the right format and the right context, DB2 can do the date and time arithmetic on those columns as well using those durations. Another thing to consider with dates and times versus timestamps is that you need to understand what your usage requirements are. So if you have a table and it requires both a date and a time, then you've got a choice. 2 columns or 1 column. 2 columns, a date and a time, 1 column, a timestamp. Obviously, there's pros and cons to each way. The date and time requires 2 columns, whereas timestamp puts it all in 1. You may be able to save storage with a date and a time. Only 7 bytes are required for those 2 columns. Saving 3 bytes with the timestamp requiring 10 bytes of storage. Now this is prior to version 10, and we'll talk about version 10 in a moment of DB2 because it gives you some more flexibility with the timestamp. The precision only goes to seconds with a date and time. We go all the way out to microseconds and timestamp. So precision is important, timestamp's the way to go. The other thing is arithmetic. May be easier using 1 column with a timestamp depending on the type of arithmetic you want to do. If you're only trying to calculate dates and don't care about the time portion of it, then maybe the 2 is more of an easy way to go. Formatting options is also a consideration. There's a lot of formatting options for date and time, less so for timestamp, but you can always break the timestamp into a date and time and then format it. I also said we'd talk more about version 10, and we will. We want to talk about version 9 as well, because each one of these breakthroughs is not an individual version breakthrough. IBM keeps adding more functionality to the feature throughout the course of releases, and we'll look at that for each of these breakthroughs. Recently, DB2.9 added additional functions for timestamps where you can more easily add intervals to a timestamp or subtract 2 timestamps to return an interval, and more formatting options for the timestamp came in version 9. Not a slew of them, but more than were there before. You only had the one option that was set at install time. Also, as of version 10, the timestamp becomes a lot more flexible. You can specify the precision for the fractional seconds of the timestamp. So in other words, what we used to have was the timestamp would have 6 locations for the fractional second. So out to 6. Whereas now you can say, well, I only want 3 or I want 10. So you can have more or less and be able to control that in a little bit more detail with the data type specification for timestamp as of version 10. Also in version 10 we get the ability to specify a time zone for the timestamp. So a lot more functionality coming in with date and times, but the bottom line is date and time support added in version 1.3 was a milestone for DB2 and was important to make it a robust DBMS. The second breakthrough is referential integrity, or RI, and this was added in version 2.1. Now, before DB2 supported declarative RI, the only way that we could ensure integrity in our database was to use program logic. That meant that any modification to the data that was outside the control of the application program would probably introduce bad data into the database. The data integrity was controlled through the program, so if you went through a report writer or QMF or DB2I spoofy to make changes, chances are the RI breaks down. And then once it was bad, there was no easy way to clean up that dirty data. You had to write a one-off program to identify and change it and fix it. And really what happened is most people just lived with the bad data because fixing it was too time-consuming. Well, with built-in RI, then the DBMS polices the content of the data structures. So by putting the rules into the DBMS and making the DBMS support the actual values that we are allowing into the columns, declarative RI, if implemented appropriately, greatly improves the quality of the data in our databases. If you take a look at this slide, you can see we've got a customer number to customer number relationship in the top table to the bottom table, and that's RI. There are a few other types of integrity here that DB2 can do, just not through declarative referential integrity. With domain integrity, that's saying that each value of the column has a valid value from the domain. So by coding the appropriate data type and length and possibly putting a check constraint on top of that, we can assure domain integrity. And association integrity is saying, well, if you take a look at city, state, and zip code, there's a relationship between these. And that technically could be looked at as a violation of normalization. But for the most part, organizations don't break down the normalization to that parts where you'd have a customer city code, and you'd use the code in the customer table, and the cities are somewhere else. But instead, we know that, for example, Dallas is in Texas, and 76543 is a zip code in Dallas, Texas. So each one of them has a relationship between the three values. They're related, they're associated, and you can do either some form of RI with other tables, like I mentioned. You can possibly do triggers to make sure that these things are appropriate. Maybe do it in the code, or maybe just not check it and assume that what goes in here goes in here. So RI done through declarative, domain integrity done through constraints and the right values, and association integrity a little bit more difficult. But RI is what we want to talk about. And as I mentioned, the system managed is generally going to be better off for you. The one thing people don't keep at the top of their mind really is they will say, well, there are rules that the DBMS puts on me if I specify referential integrity. So I would declare my primary key, foreign key relationships and the rules between them. And then that means that the system is going to impose a referential set on you because these things are related. So we want to back them up and recover them in sync. So sometimes people say, I don't want to put the declarative RI on so that then I don't have to back up and recover them in sync. All you're doing is messing up your data, because regardless of whether you code the constraint in DB2 or into your application program, the relationship is still there. And if you then back up one table at a different time than the other and then do a recovery to those image copies, your data is going to be probably messed up. So whether or not you define the rule to DB2 or not doesn't impact the way in which referential sets need to be treated, whether it's user managed or system managed. So the reason system managed is preferred is because user managed is hard to modify. It requires custom program code, works only for planned updates. The third bullet under user managed, Sometimes there's a possibility for better insert performance with user managed. What am I talking about? Well, in that situation where you've got a primary key and a foreign key, and you insert the primary key row and then several foreign key rows in the next table, insert another primary key row, several foreign keys. In that situation, your program knows you just inserted the primary key, and you don't have to go back and check that the primary key is in the table. DB2 doesn't know. So it always, when you inserts the foreign key row, is going to go back and check that the primary key is there. So in that situation, performance can suffer with system managed versus user managed. That's not a reason to use user managed over system managed. System managed 99.999% of the time. In those cases where you do use user managed, whether or not it's the right thing to do, you should code in the informational constraint. In other words, let DB2 know that there is a constraint being enforced by programs. So you would encode the constraint in the DDL and say not enforced. That way the optimizer knows about it, and the optimizer can use it as it generates efficient SQL for you. So you should always document it in the DBMS, whether it's user or system managed. Bottom line, system managed RI, better performance usually, and better integrity definitely. Number 3, our third breakthrough, is packages. And some newer programmers may not even know that packages weren't originally part of DB2. But when they came out, packages made life a great deal easier for application developers and DBAs. What a package is it's a single bound program with optimized access paths. Before packages, the only option was binding at the plan level. Now, a plan can consist of multiple programs, whereas a package is one program only. If you need to rebind one program in a plan, which has multiple programs, the only way to do it without packages was to rebind the entire plan, meaning every program. So if a plan consisted of tens or hundreds, sometimes even thousands of programs, that rebind process can take a long time. And the rebind time, that means downtime for the applications that the plan supports. But with packages, the logic is packaged at a lower level of granularity, the program level. And the plan points to the package. So when you rebind, you only need to rebind the package. Okay, maybe it helps to differentiate between plans and packages with an analogy. Think about a grocery store. Now, before you go to the grocery to buy your items, you prepare a shopping list. And when you're at the store, you put the items in your shopping cart as you find them. As you pay for the items at the cash register, the clerk paces your items into the bag. You can think of the purchased items as DBRMs and the bag as the plan. You have multiple DBRMs, your grocery items, in your plan, your shopping bag. Now with packages it works differently. Rather than actually removing the items from the shelf, you mark on your shopping list where each of the items is in the store. When you check out, you give the list to the clerk at the counter, and the clerk places the list, not the actual items, into the bag. So the bag, the plan, contains a list pointing to the physical location of the grocery items, the packages. They're still on the shelf. So you can see how managing in a packaged environment can be easier than with plans, especially when it comes to making changes. Now this slide takes a look at the program prep process. This is the compilation and the pre-compilation of the program, as well as the compilation, if you will, of the SQL. You can see the source program comes into the pre-compiler, and you get two areas, the DBRM, which is the SQL, and the modified source, which is your high-level code, your COBOL, your Java, what have you. The DBRM then goes through the process of binding either into a package prior to version 10 as well into a plan. The package would then be bound into a plan if you did that, which both of them then get stored in DB2. Whenever the program needs to be executed, then the package and plan get loaded into the EDM pool. We'll talk about that later in order for it to run. However, as of version 10, we do not allow the DBRM to be bound directly into the plan. Every program has to be bound into a package before it can be executed by DB2. Even your old ones which were bound directly into plans will no longer execute as of version 10. So packages are the way of the future. We're all going to packages. Basically, the benefits are that they improve application availability and they simplify the bind-rebind process. Another big benefit, you can have lower granularity of the bind parameters. If you were binding a plan with multiple DBRMs, all of the parameters, your isolation, your release, your other specifications, had to be the same. By binding the packages independently with their own parameters and then into a plan, you can have more control over that. And there's also the ability to do versioning with packages. Okay, number 4 in our top 10 breakthroughs is data sharing. And this came in as of version 4. And version 4 was a big release, as we'll find out. Probably, if I only had to choose one feature that was the biggest improvement to DB2 over the course of 30 years, it would be data sharing. Now, as the name implies, what data sharing enables is the sharing of data between DB2 subsystems. You can have a collection of one or more subsystems that's sharing data like this, and that's called a data sharing group. A DB2 subsystem that belongs to a data sharing group is called a member of that group. And each member can belong to one and only one data sharing group. All members of the data sharing groups share the DB2 catalog and the directory, and they have to reside in the same MVS parallel sysplex. Now, access to any of the members of the group allows you to access any of the data in the group. So I can get onto one DB2 subsystem and access data from multiple. So what this does is it allows failover and it allows greater availability. Also, what it means is that the members of the group have to reside on shared disk. Now, why is this important? Well, before data sharing, think back to the way in which things were handled, pre-version 4. I've been using DB2 since version 1, so I can remember this. If you had an application and you needed to have DB2, then you had this thing called the critical mass, meaning everything that was required to access DB2 had to reside on the same system. The TP monitor, TSO, IMS, KICS, SPF. All this critical mass had to be on the same system. So if a shop used both CICS and IMS to develop DB2 applications, then you'd have to have IMS, CICS, the DB2 subsystem, and a TSO subsystem, because generally DB2I is going to be required, all on the same CPU. And when an error occurred, couldn't really move those things around independently without losing DB2 access. Larger shops could quickly chew up resources in this type of a situation. Well, with data sharing, it's possible to enable multiple DB2 subsystems to access the same data, freeing up resources, enabling a more flexible configuration, expanding your capacity, and improving your availability. There's no special programming required to give you improved data availability, extended capacity, very flexible configuration, and improved transaction rates. So basically, data sharing gives us a much more flexible, much more available, much more foolproof, fail-proof environment in our DB2 infrastructure. Number 5, also a version 4 implementation, and this is the Type 2 index. The Type 2 index, when it came along, completely redesigned the structure of DB2 indexing, and it removed perhaps one of the biggest performance problems that DB2 ever faced, index locking. Now, if you never used DB2 prior to version 4, then you probably don't even think about index locking, because the new Type 2 index, which is the only index supported nowadays, when you lock the data page or the row, it also locks the index key. So, because locks aren't required on index pages, contention due to index locking gets eliminated. So generally, performance of your applications significantly improved as a result of your type 2 index. So type 1 versus type 2 indexes. They're both B trees. However, a type 1 index had what was called a subpage. So you had a 4K page that was broken up into smaller subpages. This was required because index rows are smaller than table rows. So you really wouldn't want to lock a full 4K index page because that could cause bottlenecks because more index keys would be locked than data pages. So you have 4 rows on a data page, say, and 20 rows on an index page. You'd lock all 20, but you only had 4 locked on the actual data page. Could cause contention of simultaneous access. So you'd break up that index page into 2, 4, 8, or 16 subpages. Type 2 indexes removed the subpaging, didn't have to worry about it because there's no locking, generally more efficient, and solved a huge major problem for DB2 applications. Next, the 6th breakthrough, and the 3rd in a row that came from version 4. Significant version for DB2. Stored procedures were added then. Now, a stored procedure is basically a program that's stored in the database server, and it's invoked by a call issued through the database. Can be written in SQL or another language. Now, when DB2 first introduced stored procedures, there was no SQL support in them. Over time, that changed. Also, it's important to note that DB2 is kind of late to the game getting into stored procedures. I think Sybase was the first DBMS to provide stored procedures, and Oracle and SQL Server came along pretty quickly afterwards, and DB2 was a little bit later. The ability, though, to write the procedure and have the database code reduce network traffic as of version 4 was a significant improvement to DB2 and a significant ability to create distributed client-server applications accessing DB2 host data as a server. The big benefits: network traffic for distributed apps. Why is that? Because every time you call the procedure, it can have multiple SQL statements in it. So you call the procedure across the network, the statements are executed, the results come back. Whereas without the network traffic, each SQL statement is a call across the network. And as we all know, in distributed apps, network traffic is generally the biggest potential performance bottleneck. Stored procedures help alleviate that. Some of the other benefits: consistency. If you code them appropriately and every time you need the logic in the procedure, the applications that need it call that procedure, it's going to consistently behave the same way. With the code in the same place, you get ease of maintenance. You only change it once in the procedure instead of potentially in multiple applications. And that's generally the benefit you get with reusable code, right? Flexible development choices. At least as of today, you've got multiple high-level languages, Rex and Java and COBOL and Assembler and C and what have you. But you can also code it in SQL today inside of DB2 as well, the SQL-PL language. And stored procedures can access non-DB2 resources. So you can access DB2, you can access IMS, or a flat file, or a vSAM file. So a lot of functionality can be coded into stored procedures. Now, I mentioned initially stored procedures were not the full-fledged, full functionality implementation they are today as of version 10 in DB2. Originally, you could only code them in a few high-level languages. COBOL was the predominant one that was used. There was also this thing called a SPAS, or a stored procedure address space. All the stored procedures ran there. And the reason for that was because they didn't want your code running in a DB2 address space so that your code would bring down DB2. Instead, your code running in the stored procedure address space can bring down the stored procedure address space, but it's not going to cause DB2 to crash. As of version 5, Workload Manager replaced the stored procedure address space, and as of version 9, native SQL stored procedures no longer even need Workload Manager. Version 5 brought along the ability to return result sets. Version 6 added the create procedure capability and SQL stored procedures. However, the version 6 support for SQL stored procedures caused the SQL to be converted to a C program, which then had to be compiled. So in order to use SQL stored procedures, you'd write it in SQL, but you had to have a C compiler. Native SQL stored procedures introduced in DB2 9 were written purely in SQL, run inside of the DBM1 address space, right in DB2. And that's because it's SQL, and SQL runs in DBM1 like any other SQL. And also there's zip eligible. A zip engine is an external engine, an extra engine that is added to the mainframe that can have work offloaded to it, and it is not chargeable from a software billing perspective. So you can get a reduced cost by calling stored procedures through distributed connections that are native SQL as of version 9. Few guidelines with stored procedures. You want to create reusable components. Anything you can do to reuse the logic and let people know it's there, document it. If you don't let people know it's there, it won't be reused. So create reusable components and document. Keep it simple. Make each procedure do one and only one thing. Instead of saying, well, here's a procedure and it does 99 things, and depending upon the parameters you send to it, that's the logic it'll do. Instead, break it up into multiple procedures and have it do that one thing really well. Triggers is the next breakthrough, and that came about in version 6. And this is our 7th breakthrough. A trigger you can think of as a stored procedure that is automatically run by the DBMS when an activity is fired. That's a high-level way of thinking about it. Basically what it is you set up the trigger as code that says whenever I do an insert, an update, or a delete to this table, this is additional code that I want to run. What it's doing is causing the database system to become active. So you say, when I insert a row to the customer table, I also want to delete a row from this table over here, or I want to update data in this table over here. And then whenever you do that insert to the customer table, that action happens automatically because the trigger is coded on DB2. The database is taking actions because of the data that's being added to the database. Good uses for triggers: whenever you want to subsequently modify data, whether insert, update, or delete, to another table when an activity such as an insert, update, or delete happens, triggers a good use to do it. You can put your business rules there. If you've got redundant data, it's a good idea to have only one of the tables contain the data that's changed by the users, and the redundant data have a trigger that automatically manages the redundant data to be the same as the data that the users change. Derived data. You really shouldn't store a lot of derived data in your base tables, but if you do, don't modify it other than through a trigger. And when the data that is used to derive the formula, when it changes, automatically have a trigger that calculates a new value and stores that where the derived data is. Now again, DB2 is late to the game with triggers as it was with stored procedures, but it's done a great job of implementing them when they're there. Now there's some impact on DBAs when you move to triggers that you have to be aware of. You know, things like monitoring and tuning, and yeah, that's obvious. There's different behaviors. There's statement versus row at a time behavior. A statement trigger is going to fire even if no rows are impacted. In other words, I did an insert and the trigger fires just because I did the insert. A row at a time behavior is going to say, I've inserted 20 rows. It's going to fire 20 times, one for each row, but only if the row is impacted. So if no rows are impacted, the row at a time trigger may not fire. Cascading triggers can cause issues for DBAs, where you've got a trigger that fires and causes data to change, which fires another trigger, which causes data to change, which fires another trigger, and so on. And if you get to the maximum number of nesting, which I believe is 16, everything rolls back, and that can be a lot of effort with no work actually being done. So you've got to be able to know what type of cascading changes can happen. The order in which triggers execute, if that's important, if you say this one has to fire before this one, there's no way of telling DB2 how to do that. What happens is when multiple triggers exist of the same type, meaning insert, update, or delete, on the same table, then they fire in order of creation from oldest to newest. Okay, so be careful in the way you create table triggers, and also if you have to drop and recreate triggers, be careful there, because if you drop the one you created first and there's others and then recreate it, the order just changed, so you might have to drop them all and recreate them all. Finally, the other big issue is access paths. When you create a trigger, there's SQL, and that SQL has an access path. And generally, we want an explain of that so that we know what that access path was. But when we bind the trigger, it doesn't give us that. So we create the trigger, it creates a trigger package, we generally will immediately then say rebind trigger package explain yes, so that we get the access paths. It would be much better if the create trigger had an explain parameter on it, but that's not there. I want to briefly mention procedural DBA, because once we have the stored procedures and the triggers, as well as user-defined functions, which I didn't really mention because I don't think they're as significant of a feature, that there are impacts on what the DBA needs to do in order to manage these things. They need to get involved in the development and debugging process. They need to get involved in the administration process. They need to know how these things perform. They need to be there for design reviews and make sure that this whole process from development to debug to implementation is done in an appropriate manner. Additionally, they need to take this database code object, this trigger, the stored procedure, this UDF, and do the things they've been doing with any other SQL, which is things like tuning, debugging, coding or assisting in coding, explains, and then augment it with these other areas here in white, resolution of the schema, trigger firing order, or some of the other things that I talked about. These are things that if you don't have a person dedicated or a team dedicated to making sure these things are done appropriately, they'll fall through the cracks. So when you start implementing stored procedures and triggers, you really need to start looking at procedural DBAs to manage those constructs. Also, as I've looked at the other breakthroughs, with triggers, IBM has still continued to advance. In version 9, we get a new type of trigger, the instead of trigger. It's not like any of the other triggers which are put on tables. Instead of triggers are put on views. So with an instead of trigger, you can take a view that's not modifiable and make it modifiable. So you can't modify a view, generally speaking, of a join, correct? Because it goes to multiple tables. So you try to modify that, DB2 chokes, and it says, you can't, I don't know what to do. Well, the instead of trigger put on the view will break apart the data that is being inserted, updated, or deleted and target it to the right component of the view. You know, a 3-table join, it goes to this table or this table to this table. So the instead of trigger is the logic you code to put the data into the right table when someone tries to do an insert, update, or delete to a view. So there's a lot of nice features and functionality there. The link at the bottom of the slide is an IBM Developers Works article that talks all about instead of triggers. It's a DB2 Linux, Unix, and Windows focused article, but the implementation is the same on both LUW and ZOS. Breakthrough number 8, multiple buffer pulls. And I couldn't target this to just one version. It's really been version 3 through version 6. And Basically, the point here is that in the early days of DB2, back when dinosaurs roamed the earth, the best practice advice was just put everything in BP0 into one buffer pool and let DB2 manage it. And you're going to be better off than breaking things apart. Now, I never really was able to pinpoint the person who said this, but it was general knowledge, and just about any DBA that I talked to back then had heard that knowledge. And it might have been reasonable in the days when you only had 5 buffer pools, 0, 1, 2, and 3, as well as the 32K buffer pool. However, we now have 80 buffer pools, and there's 80 of them for a reason. And that reason is not because you should put everything in one. There are 54K buffer pools and 10 each 8K, 16K, and 32K buffer pools. The idea here is that you want to put like data into a buffer pool and tune the buffer pool for the type of data that's there. Is it accessed randomly? Tune the buffer pool for random access. Is it accessed sequentially, meaning get in, get a lot of rows in a sequential order? In that case, you can tune the buffer pool for sequential access. So, are the tables accessed at the same time? Maybe break them into separate buffer pools so that one isn't overwriting the other. So there's a lot of things you can do to move your workload around and have the buffer pools support that workload, optimizing the system as it goes. Some ideas: you want to isolate your system information, your catalog, into BP0, BP8K0, and BP16K0. Over time, as the catalog structures increased in size, they increased in page size. So it's not just one 4K pool required for the catalog, it's multiples. If you do nothing else, and today everything is in BP0, put your indexes in BP1 and your table spaces in BP2. This will cause your large sequential scans of table spaces not to overwrite your index data, hopefully leaving the index data in memory longer. If you do nothing more, just doing that can help. But really, using more than just that can be very helpful. Other things to do: look at your heavily hit data, maybe put it in a special buffer pool. Your sort work data, I like using BP7 for that because it matches up with the DSN DB07 sort workspace. Really though, there's no silver bullet approach. Work around with it, see what works best at your shop, but use multiple buffer pools. Again, IBM is making enhancements over the course of the versions, and we see version 10 add some buffer pool enhancements. Whereas the OS improvements in System Z synergy, some memory allocation improvements so that the buffer pool is, the memory for it is allocated as data gets brought into it instead of immediately at startup. And the 1 megabyte page size in the System Z10 enables DB2 to manage larger buffer pools better. So we get better support. And really, we've had architectural limits being expanded too, not just buffer pools. Version 8 is a big breakthrough, number 9, in terms of the architectural limits it broke through. It was perhaps the biggest impact ever on DB2 because it was re-architected to support 64-bit architecture instead of the earlier 31-bit. We see that this required new hardware, a new operating system, Unicode supported in the catalog. We got 64-bit addressing, meaning 16 exabytes of addressing capability, which is a significant amount, probably take most of us to our retirement. We've got long names, up to 128 bytes in some circumstances, and table spaces with larger page sizes in the catalog. It was a significant re-architecture of the DBMS, and really there was more new lines of code in version 8 than there were lines of code initially in version 1 of DB2. So, huge breakthrough. One of the other things we saw was the EDM pool split up. Earlier I talked about the EDM pool, and that's the area where you put structures while your programs run that the programs need to access. Things like the DBD, so you can get to the data, your skeletons, your cursor tables and package tables for your plans and packages. Well, version 8 split it into 3 specific pools. The EDM pool for your cursors and package tables and your skeletons, And then the DBDs were split off into their own pool, and your dynamic statement cache into its own pool. Previously, that was all lumped together into just the EDM pool. Version 9 made additional changes where it broke apart the skeleton pool, so it took the skeletons out of the EDM pool into their own pool, and then also took a portion of the cursor table and package tables in the EDM pool and moved it above the bar. Okay, you're probably saying, what's he mean by above the bar? For that, a little history lesson. Here we can see, in the old days, the 24-bit architecture, we had below the line and above the line when MVSXA came in 1981, because we went from 24 bits to 31 bits. Previously, everything had to fit within 24-bit architecture because that's all that was there. When MVSXA came in, we created 31 bits, so we had a lot more storage above the line, the 24-bit line. Now, we move to 2001 with ZOS and 64-bit addressing. Now we've got the bar. So the line was at 24 bits. The bar is at 31 bits. So anything above the bar, from the 31-bit addressability to the 64-bit addressability, a lot more space available to us. So what we want to do is take this constrained area from below the line to the bar and move it above the bar. Anything that's being able to do that frees up resources below the bar where some things still have to be because of the way they're coded. Now again, this isn't to scale. This is just a very high level drawing to explain what I meant by above the bar. Okay, number 10. We're in the 10 breakthroughs that changed DB2 forever. This is also a biggie, and it's database definition online, or you may know it as online schema change or online schema evolution. And what it is DB2 giving us the ability to make changes to our database structures without having to bring the database down. So you don't have to stop it, you don't have to stop access to it, make changes as operations continue. And in this day and age of 24/7/365 support, being able to do that is a significant change and improvement. Before version 8, there were a lot of common changes that just weren't supported by Alter. And there still are some changes that aren't supported by Alter, but more and more are being added as database definition online is improved by IBM. So we saw the ability to make some changes added in version 8. Before that, you had to drop and recreate the object. And we'll show you an example of why that was a significant problem. That specifically because it caused an outage, but the size of the outage sometimes people don't think about unless they've actually sat down and done one of these drop and recreate type changes. Here's an example. Prior to version 8, if you wanted to change a character 10 column to a character 15, you had to take these 11 steps. Unload the data, drop the table, modify the DDL, recreate the table, recreate the objects that were dependent upon the table, rebuild the authorization for the table. Authorizations for all the dependent objects also needed to be rebuilt, reload the data with the new 15-byte column, run the utilities, run stats, copy, etc., rebind all the impacted programs, and now test to make sure it worked. Okay, I said that very fast, but you're not going to do that very fast. That is a significant amount of work for the DBA and a significant outage for the application as it goes through this change. Vendors have made a living on selling tools that automate this so that DBAs don't make errors during that process. Well, version 8 simplifies some of this. You can extend the length of a character column to a greater size. You can't make it a smaller size, but it can make it a greater size. And you can change the data type within a family. So a character to a character. So I can change character to variable character. Numeric to numeric. I can change a integer to a decimal. Date time to date time. I could add a column to an index. I could change padding on an index. I can change the clustering index. All of this using online schema evolution in version 8. Partitioning changes also were much more simplified. The ability to add and rotate partition, changing boundaries of partitions, and rebalancing them so that the data was about the same for each of the partitions. These were done using combinations of the alter statement and DB2 utilities. After version 8, we see more and more database definition on demand, online schema change capability being brought into the product. No build 2 phase as of version 9, the ability to clone tables, renaming a column, renaming indexes. Version 10, altering page size, data set size, segment size, altering simple or segmented table spaces to a partition by growth universal table space, as long as there's only one table in it. Taking a classic partition table space to a partition by growth or range partition universal table space, or altering an index's page size. All these things previously required dropping, recreating a lot of downtime. Now, with these changes through version 8, 9, and 10, the ability to make quick changes to DB2, right there. So those are the 10 breakthroughs that I think have changed DB2 forever. But I usually get some questions at this stage saying, well, aren't there some other important breakthroughs? So some of you might argue with my choice of what the top 10 breakthroughs really are. Here's some of the ones I hear about. Temporal support in version 10. Yes, that could be a significant breakthrough. I just don't see it implemented enough in enough shops yet to cause it to be one of the big changes in DB2. But I think it has legs going for it. Pure XML in version 9. That was a big change. I agree with you. However, I see Pure XML used more in Linux, Unix, Windows implementations than I do in ZOS implementations. Now, eventually it might work its way into the mainframe, but it's not quite there yet. The one that I think is the closest is real-time stats. And that came in version 7. And with real-time stats, DB2 is automatically gathering statistics to determine when you should be running your utilities. So you don't have to run stats to determine, should I run a copy, should I run a reorg. I can just look at my real-time stats to see when I need to run a utility. And that saves us some time and effort, and it's pretty pervasively implemented and used in DB2 shops as of today. Lob support in version 6, another one that there are some shops that really rely on it, but it's not really ubiquitously implemented. Parallelism, the ability to access your data in parallel in a single SQL stream as of version 3, version 4, version 5, different types of parallelism. Again, nice feature, not really a breakthrough. And one that really could be here is the advent of UDB, or as it's called today, DB2 LUW, or as it was called when it first came out, OS2 Extended Edition Database Manager. So when it turned from Database Manager to DB2, that was a significant turning point in the marketing of DB2 and in the history of DB2. But I wanted to keep this somewhat of a separate presentation between ZOS and the LUW world. So what lies ahead? Well, there are many changes that are likely to happen, probably in terms of features and functionality that are going to be near and dear to a lot of our hearts. More performance focus, more of an availability focus, more usability. But what will DB2 version 20 look like in the year 2043? Well, I hope I'm around to write about it in the year 2043, but I don't know if I will be or not. Maybe I'll be retired somewhere, or maybe I'll be here talking to you 30 years into the future. That'd be good for both of us, because I'd be 80. That'd be really good for me. I'd still be alive. But anyway, there's really no guarantee that a version 20 is going to be available at all or before the end of 2043. And my mentioning it in this presentation is not indicating an actual future version or release of DB2. I had to say that to keep my friends at IBM out of trouble, so the legal disclaimer is there. Anyway, thank you for joining me today on 10 breakthroughs that changed DB2 forever. I want to briefly mention that I've got a couple of books out that may be useful to some of you. The DB2 Developer's Guide, the 6th edition, is freshly minted. It's available now. It covers up through version 10, which is the current version of DB2 available. It's available at Amazon.com, or you can link to it from the front of my website. The homepage at mullinsconsultinginc.com has a link to it. I also have a database administration book, which was published late last year in its second edition. And this is not focused specifically on DB2, but on the role of a DBA. What are all the things a DBA has to do? Let's look at the practices and procedures. And I give examples in SQL Server and Oracle and DB2. And it's used in a lot of college courses to actually study database administration. So with that said, I want to thank each and every one of you for attending the presentation today, and hopefully we'll be looking at the breakthroughs that change DB2 forever as we move forward into versions 11 and onward. Take care and enjoy the rest of Schwug's Summer Camp 2013.